For example number 2, we're asked to analyze the critical points of the function f of x is equal to x to the third minus x. So again, we're looking to analyze the critical points. So what we're going to do is we're going to find the critical points first. So f prime of x is equal to 3x squared minus 1. So we set that guy equal to 0, and we solve that to get x is equal to plus or minus the square root of 1/3, which we know is plus or minus the square root of 3 over 3. Okay? Now, what we're going to do is we're going to take that. Now, this is just the x value for the critical point. Okay, it's not the y value, so it doesn't tell us what the height is at. We can figure that out by plugging that back into here if we want to. So let me actually do that for you. So f at the positive square root of 1/3 is equal to the square root of 1/3 to the third minus the square root of 1/3. Well, this gives us 3 square roots of 3 over, I'm just going to take this guy, multiply it together 3 times, over 27 minus the square root of 3 over 3. Well, this gives me the square root of 3 over 9 minus the square root of 3 over 3, which is going to give me the square root of 3 minus 3 square roots of 3 over 9, which looks like it's going to give me negative 2 square root of 3 over 9. Now this ordered pair, square root of 3 over 3 and negative 2 square roots of 3 over 9, that's the actual critical point. But we're really only concerned with the x value. Now let's take a look at f double prime at these two guys. So f double prime is going to be equal to 6 times x. I don't want to have those parentheses in there just because it's clutter. And now we notice that we got one of these guys that came out. There's two answers here. One came out as positive, the other one came out as negative. So f double prime at the positive guy is going to be positive because clearly this is linear. So this is going to be, it's not just because it's linear, it's because it's linear and passes through the origin. Okay, more specifically, it doesn't have an intercept value. So square root of 3 over 3 is equal to 6 times square root of 3 over 3, which is 2 square roots of 3. Now, 2 square roots of 3 is clearly positive. And since it's positive, that means the rate of change of the derivative is going up, which means that this guy right here must be a local. When I say this guy, I meant the positive version of it, so I'll do it down here. This guy right here must be a local minimum, because if you think about the way a minimum would look, we would have tangent lines increasing their slope. So the rate of change of tangent is increasing. Even though tangent's negative here, positive here, it is increasing over this entire range, and that's what we're looking at with the second derivative. Now, of course, when we put a log in the negative, we'll get something that's negative here, and so that means that, and I'll do this out here, f double prime of negative square root of 3 over 3 is going to give us negative 2 square roots of 3, which is clearly less than 0. And so that'll give us a local maximum. I always remember to think about the second derivative as opposites. So even though it's positive, you would think positive means a top. Well, positive for a second derivative means we're in a valley, and negative for a second derivative means we're up like this. So the concavity is concave up, concave down.